Hello? Can you hold, please?
Shalom and welcome everyone. I want to welcome you once again and join me on Checkpoint Training Bytes. Checkpoint Training Bytes is where we bring advanced training on Checkpoint products, features, and blades. In this training module, we'll be looking at a very important Checkpoint utility called the FW Monitor. The FW Monitor is a very useful tool that can be used to diagnose and troubleshoot how packets are being processed by the firewall kernel. And also in this module, we'll be seeing how and when to run FW Monitor. We'll also discuss how to read and how to comprehend the FW Monitor output. But before we get started, let's take a few moments and take a quick look and rundown of the agenda of this training module. First, we will start this lecture by discussing what FW Monitor is. What is the purpose of FW Monitor? And here we will discuss when it will be appropriate to use this tool and how this tool can be used to help diagnose, identify the cause of connectivity and connection failures. Second, we will discuss the differences between traffic flow and packet inspection. Here will be mostly a review of how a firewall works, how a checkpoint firewall inspects traffic. We will look at the flow of the traffic from the client to the server, and back from the server to the client. And here is where we will take a look under the hood of how a checkpoint firewall inspects traffic with regards and relationship to traffic flow and traffic direction and traffic inspection. Third, we'll talk about the firewall kernel architecture and also discuss the firewall chains. Here is where we talk about the two inspection points, the inbound chain and the outbound chain. In these chains is where the firewall code sits. And here we will look at how the firewall treats and inspects packets differently in relationship to packets either being inbound or outbound packets. Fourth and finally, we'll take a look at a few other inspection modules, what they are, and how and where these modules process packets. We will discuss some pre-firewall inspection modules and also some post-firewall inspection modules. And here is where we will look at how some of these modules are either running pre or post firewall inspection. And here we also give you some tips on how to discuss where the modules are located in the inspection chain and how to easily identify where the inspection modules are located in the kernel. So now that we've viewed the agenda for this training module, let's take a look at our first topic, what is FW Monitor? The best way to explain FW Monitor is to have a console connection. If we type on the console the FW Monitor command, it's going to do some compilation. And then it's going to capture all the data that's going through the firewall kernel, all the data that's going either to the firewall or through the firewall at the kernel level. The FW Monitor is capturing that information. And so we say that the FW Monitor is a packet analyzer, very similar to a TCP dump and to a Wireshark capture. You can use FW Monitor to capture and help you analyze the traffic flow. The FW Monitor captures all the data that is being handled, inspected, and processed by the firewall kernel, by the firewall code in the kernel. You can use FW Monitor to track packet inspection within the kernel to give you a full picture and breakdown of the data stream inside the kernel. You can use the FW Monitor utility and use the same syntax on all hardware or operating system that is running the checkpoint firewall. You can use it to capture data for all checkpoint gateways, all checkpoint appliances, SMB appliances, Maestro appliances, Quantum appliance, and open servers, etc. You can use FW Monitor to capture the packets that are being processed in the firewall kernel in the PCAP format, which will allow you to open the files using Wireshark program, which will help you filter and search for all relevant data. With all these points in mind, we first need to break down the firewall kernel inspection process before we can dive into the FW Monitor utility. Before we dive into the FW Monitor tool, let's take a step back just a little bit to refresh your memory on how a firewall works. As I mentioned before, that the checkpoint firewall always inspects the traffic twice. Once in the inbound direction, and then again the packet is inspected on the second time in the outbound direction. Now it's important to stress that the inbound and outbound inspection is done in relation to the direction and flow of the packet. This is very important. So let me repeat that. The inbound and outbound inspection is always done in relation to the direction and flow of the packet. Let me give you an example to help make this point clear. Let's add a client and a server to help clarify the direction. Let's say now that the client is communicating to the server. So here we have an internal interface which is toward the client. And so this becomes the external interface since it's located towards the server side. Or to be more specific, the external interface is always towards the internet. And so this perspective does not change. Regardless where the client and server is, this is really always in relationship towards where the internet is. Whatever internet is, then this becomes your external interface. So even if the client is located on the external side, on the internet side, and the server is located on the internal side, on the inside of your network, like a web server or mail server, again, this perspective does not change. This is still the external network, since it's facing towards the internet side. And this is still the internal interface, since it's facing the internal network. And I think this is clear and obvious to you all. But there are 2 points that I'm trying to make clear. So bear with me for just a little bit. And these 2 points are a minor and a major point. Let's first start with the minor point. The minor point is, and the point I'm trying to make is that the internal interface and external interface does not change at all, regardless if the packet is coming inbound on the internal interface or coming inbound on the external interface. This is still and always will be the external interface, and this is still and always will be the internal interface, regardless if the packet is inbound or outbound. But the inspection point does change. It always changes based on the direction of the packet flow. A packet can be coming inbound on external interface, or a packet could be going outbound on external interface. And the same thing applies to the internal interface, or any other interface for that matter. A packet can be coming inbound on internal interface, or a packet could be going outbound on internal interface. And so if the client is on the internal network and the server is on the internet, then when the client sends a packet to the server, then this is the internal interface, inbound interface. And then we have the outbound interface on the external network. And so when the server replies back to the client, this is now the inbound interface, which is on the external network, and this is now the outbound interface, which is now on the internal network, the internal interface, correct? And this is the point I made earlier, and I stressed it twice already, but I think the third time is the charm, is that the inbound and outbound inspection is always done in relation to the direction and flow of the packet. So notice how the interfaces do not change in relation to the flow of the traffic, but inspection did change in relation to the flow of the traffic. And now the major point that needs to be made, and I'm not sure I've made it yet, is that the firewall inspects packets differently in relation to them being inbound packets or outbound packets. Certain firewall inspection functionality is done on inbound interface, and then certain other functionality is done on the outbound interface. Let me draw this to give you a different perspective, which I think will help me clarify this point a little bit better. Here we have the inbound inspection, and here we have the outbound inspection. We call these the inspection chains. This is the inbound inspection chain, and this is the outbound inspection chain. But we more commonly just refer to them as the inbound chain and the outbound chain. The firewall inspection code will be enforced on both the inbound chain and also on the outbound chain. So if a packet is coming in to the internal interface, it will be inspected by the firewall code in the inbound chain. And if a packet is leaving the internal interface, it will be inspected by the firewall code on the outbound chain. The same thing happens on the external interface. If the packet is entering the external interface, it will be inspected by the inbound chain, inspection chain. And if the packet is leaving the external interface, now you guessed it, it will be inspected by the outbound inspection chain. And so as mentioned already, and several times, is that some functionality is done on the inbound chain and some functionality are done on the outbound chain. Let me give you a few examples to help clarify and help make this clear. If a packet is inbound, it will need to be inspected and matched by the rule base. And also maybe it may need to be logged. That is if logging is turned on for that rule. But if the packet is logged on the inbound chain, then it will not need to be logged again on the outbound chain. You only need to log once. Either the packets are accepted or dropped, and one log is all that is needed. There is no need to log again on the outbound chain. Here is another example. Let's take NATing. NATing can happen on either inbound chain or it can happen on the outbound chain. It really depends on how and what NATing you have enabled or how complex you have configured your NAT rules. But for simplicity's sake, in this example, when hide NAT is enabled for the source, then NATing will be done on the outbound chain. Or when static NAT is enabled for the destination, then NATing will be done on the inbound chain. I don't want to go too deep into NATing in this video, but I hope you get the point, which is that different functionality can happen to a packet on the inbound chain versus the outbound chain. Now let's take this up a notch just a little bit. Not only is the firewall code running on both the inbound chain and the outbound chain, but we also have some other products and multiple inspection points on the inbound chain, and we also have some other inspection points in the outbound chain. Firewall is just one component that is running on the inbound chain and the outbound chain, but depending on what products and blades you have enabled, you will have a few inspection points for other products before the firewall code and some other products inspection code and functionality after the firewall code. We call these products that are running in the kernel modules. In the kernel, we have multiple product modules running and inspecting the packets. And so we have some inspection points for products and modules that can happen on both chains. On the outbound chain, we have some product codes and functionality to inspect packets before the firewall inspection code, and we also might have some product code and functionality inspecting packets after the firewall code. I will show you later in this video exactly what these modules are. But for now, let's assume that we have some of Checkpoint's other products enabled, like perhaps SecureXL, ClusterXL, IPS, VPN, etc. And so once we've enabled a bunch of Checkpoint products and features, we will be turning and enabling a bunch of other inspection codes, inspection modules for these other products, depending on the products or features being enabled. Some product codes will be loaded in the inbound chain, and some product code and functionality will be loaded and running on the outbound chain. It really depends on the products you enabled. Some products and blades might load some code and inspection on both inbound and also outbound chain. And also it's possible that some code will be enabled before the firewall code on the inbound chain, and some other products code might be enabled after the firewall code in the inbound chain. And this applies and is also true for the outbound chain as well. Some inspection code can be enabled before the firewall code on the outbound chain, and some inspection code can be enabled after the firewall inspection code on the outbound chain. This really depends on the products that customer has purchased, licensed, and enabled. Now let's go on to the next topic, which is really a language and lingo that Checkpoint and Checkpoint savvy users use, which will help us identify where things are broken or where things are not working. So if some code and functionality is broken or not working, we can identify it rapidly as pre or post firewall modules. If some inspection code is dropping the packet before the firewall inbound chain, we call it the pre-inbound chain. Or if some module code or functionality is dropping the packet after the firewall code in the inbound chain, we call it the post-inbound. The same thing applies to the outbound chain. We refer to any chain inspection code before the firewall code in the inbound chain as pre-outbound, and after the firewall code as post-outbound. And so, when you're talking to a Checkpoint engineer or a Checkpoint customer, and then when we need to refer or reference some things that are dropping the packet pre-inbound, we're talking about a product before the firewall code. Or post-outbound, we're talking about an inspection point after the firewall module on the outbound chain. One more time to make sure this is clear before we move on. Anything running before the firewall code, we call it the pre-inbound. Anything running here after the firewall code, we call it the post-inbound. Anything in outbound chain that's running before the firewall code, we call it the pre-outbound. And anything running after the firewall code, we call it the post-outbound. One last lingo pointer that we often use when talking about debugs, but specifically when we're talking about after monitor, is that sometimes we use a shorthand version. Instead of saying pre-inbound, post-inbound, pre-outbound, post-outbound, we say little I, big I. Little O, big O. Little I refers to pre-inbound. Big I refers to post-inbound. Little O means pre-outbound and big O means post-outbound. And this makes sense if you think about it a little bit. Anything in the inbound is referred to as an I. Small I is pre, big I is post. Anything on outbound chain we refer to as an O. Again, a small o is pre and a big O is post. So anything small is pre-firewall, like small I or small o. These inspection points are before the firewall chain module. Small I is pre-inbound, small o is pre-outbound. Anything that is big is post. Big I is post-inbound, big O is post-outbound. One final thing is where that routing engine sits. The routing engine, the routing decision, always occurs between the inbound chain and the outbound inspection chain. So going back to my previous example that we used earlier, the client sends a packet from the client to the server, either a request for UDP or a SYN packet for a TCP connection. The packet arrives on the internal interface of the firewall. Always remember the firewall code always sits in between layer 2 and layer 3 of the OSI layer. The firewall inspection engine is part of the whole inbound inspection engine. Packets will be inspected by the whole inbound chain. It will first be inspected by the pre-inbound chain module, then it will be inspected by the firewall inbound chain module, and then it will be inspected by the post-inbound chain module. If all the inspection points along the inbound chain module approves or inspects and accepts the packet, then the packet is processed and moved up to the TCP stack up to layer 3. Layer 3 is where the routing engine sits. The routing engine makes the routing decision or where to route the packet. In this case, the packet is routed to the external interface. Again, we have the firewall inspection code that sits in between layer 2 and layer 3, but now this is the outbound inspection code. Again, the packet will need to be processed and handled first by the pre-outbound chain module, then it will need to be inspected by the outbound firewall inspection module, and then finally it will need to be processed by all the other post-outbound chain modules before the packet can be sent on its way to the external interface, and then the external interface sends the packet on the wire to its true destination, the remote server. When the server replies, the whole process and inspection is repeated again. But notice that now the inbound chain and outbound chain will change in perspective to the direction of the packet. The packet arrives on the external interface, then it will need to be processed by the inbound chain module, pre-inbound and post-inbound. Then this packet is routed to the internal interface, and now it's inspected by the outbound chain module, pre and post. Pre-outbound, and then again post-outbound before sending the packet to the internal interface, which will then send the packet back on the wire towards the client. And before we let you go, let's do one more demonstration and put all these pieces together to see how they work. Let's say that the client wants to send a packet to the server. The packet will arrive on the internal interface, then it needs to be processed by the firewall kernel. Since it is an inbound packet, it will need to be processed by the inbound chain. And so it will need to process by the inbound chain modules, the little I. Then it will need to be processed by the firewall code. Here is we check the rule base. If there is no rule that accepts the packet, then the packet will be dropped. No further processing will occur. On the other hand, if there is a rule to accept the packet, then the packet will continue on its journey. Now it will be processed by the post-inbound chain, the big I. Now it's important to emphasize that packets could be rejected anywhere within the inbound chain. But if everything is allowed and processed by the inbound chain, then we move the packet to the next layer. And so the next thing that the packet is moved up to the layer 3. The layer 3 is where the routing engine sits. Here is where the routing engine will make a routing decision based on the entries in its routing table. Either it finds a route to forward the packets to the next hop interface, or it uses the default gateway as the path of last resort. But once the routing decision is made, the packet is then forwarded on to the outbound chain. This outbound chain will be processing based on the interface that was determined by the routing decision. Now the outbound chain will process the packets pre-firewall, which we call the pre-outbound inspection, also known as the little O, and the packet will then be processed by the firewall code, this time obviously by the firewall code running on the outbound chain. And again, if the packet is accepted, it is moved to the post-outbound to be processed by the post-outbound modules, what we call the big O, before forwarding the packet on the wire towards its final destination, the server. The destination, in this case, being the web server. Then the server will reply. The packet inspection and processing will be done once again, but now in the reverse direction. The packet will arrive on the external interface. It will be processed first by the pre-inbound chain module, the small I, then processed again by the inbound firewall inspection code, then inspected by the post-inbound firewall code, the big I, and then the packet is once again forwarded to the layer 3 for routing. The routing engine will make a routing decision and send the packet to the internal interface. The internal interface will be the outbound chain. The pre-outbound chain will once again process the packet. Again, we call this the little o. And then the outbound firewall code will inspect the packet once again, then forward a packet to the post-outbound chain module, the big O. Again, if the packet fails anywhere throughout these inspection checks, then the packet will be dropped. If the packet is not dropped and is allowed through the outbound chain, then the packet is forwarded out the internal interface towards the client. Again, to be sure this is clear, if the packet inspection fails anywhere during the inspection chain, either from the client to the server, from the server back to the client, if there's any failures or rejections anywhere along the inspection chain, then the packet will be dropped. And so, how do you identify where there is a potential failure? This is where we need to run the FW Monitor tool. The FW Monitor tool will help us isolate where the failure occurs. It will help us isolate if it fails on the inbound or outbound chain. If it fails on inbound, then it failed pre-firewall or post-firewall. And again, if the failure was determined to be occurring in outbound chain, then the failure occurred pre-outbound or post-outbound. And finally, I hope this video has helped shed some light on what FW Monitor is and how it can be used to identify connection failures, that is, connection failures that are occurring within the inspection chain, either the inbound or the outbound inspection chain. And so when you're able to identify where the failure is occurring within the chain, this knowledge will get you closer to resolving the problem. At least this information will help you to focus and narrow down which product or function to focus your attention on, which will help you to troubleshoot the issue and hopefully lead you to problem resolution. I created this video to discuss FW Monitor, but we first needed to discuss the foundation of how a firewall processes packets. With this knowledge, it will help us comprehend the FW Monitor utility. In the next video, we will continue to explore the FW Monitor and how it captures the packets within the kernel, within the inbound and outbound inspection chain. Before ending this module, let's take a few moments to quickly summarize the information discussed in this video. We started this video by first discussing what FW Monitor is. In essence, it is a packet analyzer, which is very similar to the TCP dump, packet capture, and we also discussed some differences between them. With the main difference being that TCP dump captures the traffic, captures the packets on the wire, meaning it captures the packets running on the network. Whereas the FW Monitor utility captures the traffic, it captures the data that's being processed and inspected within the kernel, specifically within the firewall inspection kernel. And we also discussed how the FW Monitor is used to help you to view and identify packet flows and packet direction within the kernel, which can help you to locate and isolate where, how, and when the packets are being processed, which can help you identify the issue or problem within the firewall kernel, all within the perspective of the direction of the traffic flow. And then we discussed how packets are being processed. We discussed that each packet is being processed twice, once in each direction. We discussed the differences between external and internal interfaces and how packets are being processed differently, but always in regards and in relationship to them being either inbound or outbound traffic, and how each packet can be going inbound or outbound on the external or the internal interfaces. And we also discussed how inspection will be always done differently in relation and in regards to whether they are inbound traffic or outbound traffic. And we also discussed how some products or functions will be done either on the inbound or on the outbound inspection, and how some products or functions might be done on the inbound direction or some products and function might be done on the outbound direction. We also mentioned that some products or inspection function might be done only on the inbound direction, or it might be done only on the outbound direction, or both the inbound and outbound direction. Then we talked about the inspection chain, how each and every packet is always processed by the firewall code in each chain, how each packet is processed by the firewall code in the inbound chain, and how in turn each packet is also processed by the firewall code in the outbound chain, and how each firewall code in the inspection chain will process packets differently in regards to whether they are inbound or outbound packets. We also discussed that the firewall kernel is made up of multiple products, which we call modules, or to be more specific, kernel modules, and how kernel modules are running before the firewall code, and some kernel modules can be running in inspected packets after the firewall code, and how we use specific language and lingo to identify where within the chain that the product module is located. In the inbound chain, we say that every module running before the firewall code, we call them the pre-inbound modules. And we also mentioned that the module running after the firewall code, we call them the post-inbound modules. And we also discussed that we have similar terminology to help identify and locate product and inspection that could be used or running in the outbound chain. And we call every product or function before the firewall code on the outbound chain as pre-outbound modules. And we call everything after the firewall code on the outbound chain as post-outbound modules. We also discussed a shorthand version to help identify pre and post inspection. On the inbound chain, the pre-inbound inspection modules, we call them the little i's. On the post-inbound inspection module, we call them the big i's. On the outbound chain, the pre-outbound, we call that the little o. On the post-outbound, we call that the big O. Pre or post, little, big, your choice. And finally, we also discussed the routing engine. The routing decision is always done between the inbound chain and the outbound chain. If a packet is inspected and accepted by all the inbound chain modules, then the packet will be routed to the outbound chain to be inspected and processed again.
I hope you found this video informative. I hope to see you in the next video. Until then, shalom and bye for now.
Checkpoint. We secure the future.